Hey everyone, and welcome to this explainer. Today we're unpacking a genuinely fascinating computer science paper straight from the researchers at the University of Kelaniya in Sri Lanka. It tackles a problem I can almost guarantee every single one of us has faced. We're going to see how they used advanced machine learning, not just as some abstract theoretical exercise, but to build something highly practical. We're talking about a personalized AI assistant designed to completely cure our inbox overload. I'm really excited to share this with you, so let's just jump right into it. I want you to take a second and picture your work inbox on a Monday morning. You open it up, and bam, you're immediately drowning in messages. Now think about those emails. Most of them aren't trying to sell you sketchy products, right? Your IT department's filters already blocked all that stuff. No, I'm talking about the corporate noise. You know the ones. The endless reply all chains, the automated system alerts, the memos that literally have absolutely nothing to do with your current project. It's super frustrating, isn't it? Now, what's really interesting here is the vital distinction the researchers make right at the start of their paper. We have your standard spam on one side. This is malicious, it's junk, and honestly, standard enterprise filters are already brilliant at catching it. But the real villain of our workday is on the other side. Unimportant non-spam. These are completely legitimate emails from inside your own company, but they just don't matter to you. They clog up your day, and the worst part, traditional static rules, like routing everything with the word newsletter to a random folder, they just fail here, because this noise is highly contextual, and it changes constantly. Okay, so here's our game plan for today. We're going to cover 1. The inbox overload problem. 2. A machine learning solution. 3. Finding clues in data. 4. Testing the AI algorithms. And finally, 5. Achieving a cleaner inbox. Let's start right at the beginning with section 1, the inbox overload problem. I really love this quote directly from the paper because it just perfectly validates our daily pain point. The authors write, "The importance of emails received cannot be gauged without reading the content, as a result of which a considerable time is wasted, eroding the productive time in the corporate world." Really think about that for a second. The time thief isn't just reading the bad emails. It's the cognitive load of clicking, skimming, and deciding if it even matters. That tiny little decision, repeated 100 times a day, just completely destroys our focus. So, how do we actually get that time back? Let's move to section 2, a machine learning solution. Think of this as the solution roadmap they engineered. We've got a workflow where a Python-based agent acts literally as your silent personal assistant. It just sits in the background of your Outlook client. Whenever a new email arrives, this agent automatically reads it, extracts the data, looks at your specific personalized parameters, and feeds all of that into a trained classification model. If the AI decides the email isn't worth your time, it silently sweeps it into an ignore folder before you even lay eyes on it. It's fully automated, it runs continuously, and it's highly personalized to you. But how does a computer actually know what you find important? That brings us to section 3, finding clues in data. The crucial point to remember here is that algorithms aren't magic. They rely on clues. And this brings us to a really important concept called feature engineering. Basically, it's the process of transforming raw, messy email data into a mathematical language the AI can actually understand. You see, you can't just feed a raw paragraph of text into most AI models and expect it to do its thing. You have to break the email down into specific, measurable features. To understand the actual written text of the emails, the researchers used a really clever text mining process. First, they gathered a massive data set of past emails. But human language is messy, right? So they stripped out stop words like and, the, or but. Then they used a technique called stemming. This basically chops words down to their root meaning. So reporting, reports, and reported all just become the root word report. This distills the whole email down to its core intent. When you visualize this process, you get these incredible word clouds. These were actually generated from the first author's own inbox. They visually represent the most frequent and impactful keywords from a massive data set of over 15,000 emails. By mapping the frequency of specific words like report, cost, or even specific names of colleagues, the AI is literally learning to associate certain vocabulary with high or low importance, all based entirely on the user's past reading habits. But it goes way beyond just words. The researchers programmed some brilliant human logic into the AI by creating derived features. For instance, if an email is sent only to you, the AI flags it as highly important. Makes sense, right? If your supervisor is in the CC line, you better believe the AI learns to flag that for your attention. On the flip side, if you're just one of 50 people CC'd, or if the sender is an automated system, the AI learns to treat it as lower priority.
It's essentially capturing the unwritten rules of corporate communication.
Now, before they could test any models, they had to make sure their data was fair. They analyzed exactly 15,090 emails and proved their dataset was perfectly balanced. As we can see, 52% were deemed important and 48% were unimportant. This near-even split is absolutely vital. Think about it. If the data was skewed, say 90% important, the AI would just lazily guess important every single time and look artificially smart. Having balanced data guarantees the AI genuinely has to learn the difference.
With all our clues mapped out, it's time for Section 4, testing the AI algorithms. The researchers didn't just try one single approach here. They basically interviewed 6 different digital assistants for the job. They evaluated a decision tree, a random forest, logistic regression, support vector machines, a neural network, and a k-nearest neighbor algorithm. They fed the exact same historical email data into all 6 of these to see which one could figure out the user's habits the absolute best. Evaluating these models wasn't just about some generic accuracy score. The stakes are way higher than that in your actual inbox. So the researchers used 2 very specific metrics: recall and precision. For important emails, they needed high recall, meaning the AI casts a super wide net so nothing vital is ever missed. But for unimportant emails, they needed extremely high precision, meaning if the AI takes the aggressive step of moving an email to the ignore folder, it better be 100% sure so good emails aren't accidentally buried. And the results were super clear. The rules-based models absolutely dominated. The decision tree and random forest algorithms, along with the neural network, vastly outperformed the others. Models like logistic regression and k-nearest neighbor, they just couldn't quite grasp the complex, personalized nuances of a human inbox. During tuning, the top models achieved up to 85% precision on unimportant emails and up to 91% recall on the important ones. Okay, we've got our winning models. Let's look at Section 5. Achieving a cleaner inbox. To be extra safe, the researchers implemented a really brilliant failsafe. They didn't just deploy one algorithm. Instead, they deployed the top 3 winners together as a composite model. When a new email arrives, the decision tree, the random forest, and the neural network all evaluated entirely independently. The AI only hides an email in the ignore folder if there is a majority consensus among the models. It's exactly like having a team of 3 human assistants voting on an email to ensure they never, ever make a careless mistake. And here is the final, ultimate victory. When this was deployed into a live inbox and evaluated through manual sampling, this composite AI system achieved an incredible 93% accuracy rate for emails successfully identified and moved to the ignore folder. A whopping 93%. That means almost all that useless noise was silently swept away without a single click from the user, leaving behind only what truly mattered. So, I'm going to leave you with this provocative thought. If a personalized AI assistant could perfectly filter out 93% of your useless workplace noise starting tomorrow, what could you achieve with all that reclaimed time? The research from the University of Kelowna proves for sure that highly personalized, machine learning-driven inboxes aren't just science fiction anymore. They are a mathematical reality, and it fundamentally changes how we think about our daily productivity. Thank you so much for joining me for this explainer. I really hope you found this as genuinely fascinating as I did. Keep learning, and I'll catch you next time.